Hello and welcome back to our beloved stage here at the Spanish Pavilion in Mobile World Congress 2023. We only have 4 presentations left, and they're company presentations. Sorry about that. The next company presenting for us is AEInnova. Joining me on stage soon is Raúl Aragonés, chairman of the company, and the title of the presentation is Transforming the Industry 4.0 into More Digital with the Least Environmental Impact Using Batteryless Energy Harvesting Powered IIoT. Well,
Thank you very much.
Whenever you're ready.
Thank you very much for your attention. Let me introduce how we are decarbonizing the Industry 4.0 with the least environmental impact. And the way of doing that is to recover the energy that is available in all the facilities, to convert this energy into clean electricity that powers the next generation of long-range wireless IoT devices. So, first of all, the big industries has a lot of challenges. The first one is they have heat. They need heat to transform the materials into final products. And that means in the European Union, we are losing the 21% of our all energy capabilities in form of industrial waste heat. At the same time, industries, what they want to make their maintenance, they are typically using the reactive and preventive maintenance. That means they have a lot of challenges because they are expensive, they are inefficient, and also they have safety concerns. Finally, when they move towards to transport digitally using wireless devices, all of them wear lithium batteries. And lithium batteries, these devices has a low range wireless coverage, a low data rate, also are hard to maintain due to constant battery replacements, but also they are not ATEX, they cannot operate in explosive environments, and the heat affects dramatically their lifetime. And finally, the very bad environmental impact from the extraction of the lithium towards the non-recycling of them. Our solution consists of converting heat into electricity. This solution that is inspired in the space is able to create energy from the heat easily. The solution is plug and play, allows to you to reduce your time to establish the failure of the machine due to we are applying predictive maintenance, runs from 50 degrees Celsius of heat exposition up to 150. The solution is completely batteryless and free of maintenance, has capabilities to communicate up to 14 kilometers, and then has a very good sensibility to measure vibrations in this machine to do the predictive maintenance. And how it works is easy. I attach the heat surface, the thermoelectric device, then we attach the vibration sensor in the machine under test, we communicate with a long-range wireless IoT, and finally, data travels using LoRaWAN networks to our cloud platform with an advanced tool of analytics to improve your capabilities or capacity of monitoring data. And the solution is quite cheaper compared to others in the market. So if we compare the 1,000 deployment costs of wireless devices with others without, solution is cheaper in the form of infrastructure, in form of the environmental impact, in the cost of the cloud computing, also in the purchasing cost, and finally, the maintenance. Solution is maintenance free. So the cost of maintaining 1,000 devices is practically just cleaning once a month. Also, if you apply predictive maintenance, you have several capabilities. You are going to be more successful in form of reduction of maintenance costs, elimination of breakdowns, reduction in downtimes, increasing productivity, and also reducing risk to the person. We have in the European Union and Japan several use cases we can do it now. The majority of them are in the energy demanding industries. So from the oil and gas sector, chemical, iron, aluminium, paper, rubber, deep water treatment plants, cement, textile, and the subway. All of them are projects that are fully energy harvesting projects without any kind of energy support. Just pay attention in the oil and gas sector. For example, this project done in Ferrovial Net Zero. We are harvesting the heat of this pipeline. We attach the thermoelectric device that generates energy that powers the long-range wireless IoT device, and here the vibration sensor that monitors this pump. The same approach in this scenario. The system, autonomous, has communication up to 400 meters in this case, and reduces dramatically all the costs that until that moment were done basically manual. Another example, for example, in the aluminium sector, this is the Richburg These are one of the biggest players worldwide in aluminum recycling. We attach a thermoelectric in this combustion fan, generates energy that powers the IoT. In this case, using 5G, narrowband IoT LTM communication layer, and the vibration sensor that basically monitors the vibration of this ventilator. Another example, for example, in the rubber plant in Safir, Valoriza. Here, these guys recycle tires, and with the friction of the raspers with the tire to generate the small ducts, they generate heat. This residual heat is harvested by our devices to power one vibration sensor, one temperature sensor, and two IoTs that process data in real time in this rasper. In the cement and water treatment plant, for example, we have this one. In the cement plant of Cemex, same approach. We're going to monitor vibration with a Kilk motor, just attach the vibration sensor and the IoT, and here the temperature device, the waste heat recovery device. Data travels up to 1 kilometer using LoRaWAN network, and you have all the data in our cloud platform. And this is our cloud platform. It's a very easy to use platform where you're able to incorporate predictive maintenance algorithms, where you're able to create alerts, alarms, and any kind of graphs that are useful for your day-by-day maintenance. We have other projects. We are growing faster and faster. In this case, this project is highly demanded for the oil and gas industry, where they have steam leaks, steam pipelines. A big oil refinery has more than 20,000 steam traps that evacuates the water condensate in the pipeline in order to avoid strokes. In this case, this equipment installed in IPRA, one of the biggest vaccination plants in Spain of COVID. We harvest the heat in this device and the IoT, and we listen the sound of the steam that is it's being conducted in this pipeline. And once it listens that the steam trap is locked, informs to the cloud that you must go there and fix the solution. Every steam trap in this kind of industries implies total costs for more than 5,000 euros per year due to the lock of these steam traps. Imagine 20,000 devices losing every one 5,000 euros per year. What is a big investment in energy generation? The solution reduces to zero the leakage in this kind of facilities. Also for tunnels, this is the first vibration sensor fully powered by wind. It is being done in the subway of Barcelona, and these big ventilators you have in the ceilings of the tunnels, more than 800 in Barcelona, in the subway of Barcelona. All of them monitor manually. There is a guy that goes with a wagon, elevates the wagon, touches with a vibration sensor manual the vibration of the machine, and takes notes in a piece of paper. To this point, done every 2 months, every measurement of the 900 ventilators to real time. This is the micro wind turbine that powers the IoT device, and this is installed in the rear part of the ventilator. In the same slide. So doing this, you will avoid the situation that happens in Stockholm, creating serious damages to the population, because it happens in a highway. 300 kilograms fall down from the ceiling where people were driving in this tunnel. So how we can manage this situation? Just monitoring all of them in real time, and absolutely doing and using batteryless system. In this case, using renewable energy from the heat, from the wind. Another use case, for example, in this case, is to monitor volumes in silos for the cement sector, the grain, cereals, sand. Until now, all of them were measured by weight. So you weigh the volume, the weight of the silo, and you know more or less what is the level of filling. But why now to use an also renewable energy source to monitor volumes using PV panels and narrowband IoT communication? So in this case, the project was done in Cementos Molins in Catalonia. And what we did, we installed in the top of the silo 2 different devices to test the solution. One with a LiDAR to measure volumes with a laser, and the other one using ultrasounds. And then the solution allows them to reduce dramatically all the costs in the refilling routes of these silos, when in this case the company has more than 1,000 distributed in isolated places around the Catalonia. In this case, we use narrowband IoT communication network. And that's all. If you have any question, please I'm here to attend your questions. Thank you very much for your time and your attention. Thank you.